Okay, so this is going to be NuGet, both from first principles and then a bit of a deep dive into some of the internals of package management in .NET, how you configure it, how you actually do it. So the second half of this is going to be a live demonstration, so you can watch me make mistakes in real time. That's right, I checked it all worked yesterday. It's fine. So NuGet Bootcamp, packages for you and your organization. Less about your organization, a little more about you, actually, but it's all good. Oh, I've got transitions. So that's the NuGet logo. NuGet is about probably 5 years old now as a project. It's come into mainstream acceptance in the last 3 years, and it's probably been making its way into companies and organizations in about the last 2 years. Oh, look, we're going to have transitions for everything because I set it up wrong. So, you know, the interesting thing about NuGet is it's really nothing new. So that's just a random selection of package managers that predated NuGet. You know, CPAN, the first version of CPAN, I believe, predates HTTP. So CPAN is a Perl package manager, and I believe originally it was written in 1994, so maybe a little bit after, just after HTTP was finalized. There was an official web mirror in 1997 for Perl packages and modules. Most noticeably, NuGet is imitating Ruby gems, which almost single-handedly popularized the Ruby language along with Rails. You know, Ruby would not be the household name it was without Rails and Ruby gems. And apt-get, very, very popular package management for Debian, which is more on the side of installing software and automation. Even PHP had pair in 2004. So to set the scene a little bit, we were very, very late to the party, and it was a very obvious large hole in the .NET ecosystem for a lot of years. Conspicuously hiding up there in the top right is OpenWrap. So OpenWrap was an open source .NET package manager that probably dates to about 2008, 2009. And there's a little bit of an interesting story about that. So, you know, there were package management wars in .NET. It was particularly interesting. NuGet won, but it won through dirty tricks rather than on merit initially, which I'm sure everyone likes to hope that people forget. But there were definitely some troubled beginnings because the Microsoft of today isn't the Microsoft of 5 years ago. And 5 years ago, Microsoft were just starting to really engage with open source legitimately rather than on their own terms. And part of what they did was accept a lot of criticism for extinguishing a lot of open source projects. And actually, a lot of the things that people love today had a little bit of a dramatic start. You know, Monorail did MVC before MVC existed, and as soon as ASP.NET MVC existed, the appetite for using Monorail diminished because in the .NET ecosystem, there's a lot of feelings that if it's not from the mothership, we're not going to use it in a lot of organizations. And I think that's changing a lot over time, and especially in the last 5 years, but this was a real big deal. So, you know, originally there were actually two open source package managers for .NET. There was OpenWrap and NuPack, and Microsoft blessed NuPack. What they actually did was they took its name. And there was a lot of controversy about that because basically all that really happened was the NuPack team got subsumed into the Microsoft team working on NuGet. They borrowed the user base and part of the name and launched NuGet and completely crushed OpenWrap in the process.
Were these two, they were open source themselves, or were they kind of charging?
They were open source themselves. So they were both open source and available. But the thing about package management in almost any ecosystem is it kind of makes sense for there to be only one. It's one of the few things where competition doesn't necessarily benefit the market. So Microsoft kind of did that, and since then they've been trying to be better. You know, they've been trying to grow the reputation of the project. NuGet really was one of Microsoft's first tentpole open source projects. You know, they ran it on GitHub. It was contributed to by a core team of Microsoft people, but it accepted community contributions more or less from day one. So on one hand, you have the traditional Microsoft embrace and extinguish approach of we want to do package management, so we're going to write our own not invented here syndrome. And on the other hand, you have, oh, but now we're doing this, we're going to make sure this is open and available to everybody. So, there was some good at the start. And actually, a lot of people that are working on the core NuGet team and were involved in those early days, I believe David Fowler was one of the initial core contributors, and he's the guy that's now one of the key devs in the ASP.NET vNext movement and the push for rebuilding really the whole .NET framework to be more open. So it's kind of interesting how from an early beginnings of wanting to be open source but accidentally being hostile to the legitimate approaches of open source software, they've kind of come around. So people kind of forget that now, but it was a bit of a big deal at the time. The real truth is NuGet has been a super positive change to the .NET ecosystem. So I took that screenshot about half an hour ago. That's kind of insane. That 291 million package, millions package downloads, 300K packages. That's a lot of packages, really. And what that represents is a seismic shift in the .NET ecosystem, both in the way that you get software. Literally, before then, certainly Windows and still even .NET had various versions of DLL hell. And NuGet isn't perfect. It has its own versions of DLL hell, but it's made things a little bit better. And ultimately, the amount of discoverability involved in things like the NuGet gallery, a real positive force for change. So we're in a much better place for it, despite the origins. And it works at work. And I reckon those stock photo people could be using NuGet right now. They look like they're working so hard and enthusiastically. They got one of every gender, race. They're definitely using NuGet. And you can use them privately. I really should have removed all these transitions. So what's in a package? So a package is a self-contained unit of code. So generally middleware components. So all the stuff that you use and you'll see all the time. JSON.NET is probably, I think it is the top of the charts. It's NUnit and JSON.NET are the two top of the charts NuGet packages that every single person uses. But sometimes larger applications or tools. So NuGet has conventions for packaging up build tools, MS Build extensions, and larger applications like NHibernate Profiler, for instance. NUnit is an interesting example because it has both. So packages allow you to compose your application of other components so you don't have to build them or go hunting for DLLs. And that's really the very, very core of it. They are little self-contained units of code that travel on their own. I've written a big thing about composition for applications. Read it sometime if you fancy it. But it's interesting because whilst frameworks can be distributed over NuGet, I think there's been a sea of change in the last probably 12 to 18 months where people are starting to reject the notion of big frameworks in their applications because frameworks come with baggage. Does anyone in here know what the difference between a framework and a library is? Think about it.
A framework gives you more, forces you down for more defined.
So it's about opinions, isn't it? So a framework calls you, but you call the library. So if you're calling libraries, you retain the control and the design for your application, whereas if you're building inside a framework, you are inside the framework and it's its house and its rules. And I think there's generally a sea of change towards composing applications from libraries rather than adhering to big frameworks that force you to build in a specific way. And it's very, very much, I suppose, coupled to the re-emergence of SOA as microservices. So do smaller things, less big frameworks, less enterprise, more componentization. I think that move towards libraries is quite important, actually. So it's a zip file with DLLs, isn't it? I mean, kind of is actually just a zip file with DLLs, isn't it? So the NuGet file format is a zip file, just with a different file extension. But we've been able to zip up DLLs since the dawn of time. So why would you use packages? So interestingly, it's also a distribution method for your open source or cross-cutting packages. So NuGet isn't just a packaging format. It's a server and it's a feed and it's a pattern of working. So it's a little bit more sophisticated than just a zip file. It's a great way to share middleware, like things like API client libraries. Hopefully that's ringing some little bells in people's heads that, hey, if we've got a couple of systems that call each other, maybe we need some client libraries, and maybe we need a way to distribute them and keep them versioned and make sense. So the cool thing is it's both Visual Studio and build process friendly. It works in both. You can do it all in the command line. It works in TeamCity and every other build system under the sun. I believe even today NuGet runs on Unix as well, so it runs under Mono. There's a couple of bugs around path manipulation, but it pretty much runs everywhere. And in an organization, it's a good central location for internal IP. It's a good way to audit and keep stock of the things that you have and maintain and are used. Also, if you use a gallery app, there's lots of statistics over it, so you can see which packages are used where and what your most popular software is. It's kind of cool. So people can discover your code and use it without friction. So packaging encourages an open source mentality. Packaging doesn't mean you must be open source. Internal feeds are absolutely fine, but the way of working is very related to the kind of push and pull request models of open source projects. And this is something a lot of organizations, including this one, it sees as a desirable quality because it increases code ownership whilst encouraging reuse. So it helps scratch the itch, and that itch is that I had to use this enough times that extracting it into its own thing made sense, because copy and pasting code and big file system DLL references lead you to monolithic hell. It's painful, it's almost impossible to version, it's difficult. So the itch of, I'm sure I want to use this somewhere else, is solved with package management. So your code improves as well because you code like people are watching. And in my experience, it's part of the reason I find pair programming so important and TDD important and open sourcing software is important, is that you are better because people watch you, because you don't cut corners, and you make sure you've got the test coverage and the documentation because you know that this isn't just bounded to your own brain. There are also disadvantages. So there's a mental cost for maintaining packages. And people don't really talk about the disadvantages of package management very often because, frankly, the advantages outweigh it, but they're real. Think about your average debug workflow. You're used to stepping through code files. Well, if you don't publish debug symbols in your NuGet packages, that goes away. The code becomes like any other library, any other external library. You'll probably end up maintaining multiple copies of Visual Studio, and your workflow around implementing new features may involve updating and maintaining packages. And you've got to maintain it, accept pull requests, consider backwards compatibility, consider non-breaking changes to APIs. As soon as you do this, this is a real thing. It's like pushing a website. You can't change your APIs without telling people, and we'll touch on that later. You have to be mindful of extensibility. If I like using common logging, well, common logging's the worst example because that papers over the problem. If I like using nlog and you like using log4net, what do? If you have a particular error handling pattern that you want to hook up and you won't use any code that doesn't support it, what do? Well, you've got to think that when you're building certain kinds of libraries, all of these design decisions get bubbled up to the top. So you have to be mindful that in your code design, you support extensibility or event hooks or callbacks or any of these kinds of things. It's not necessarily mandatory, but if you're building a library that you want people to reuse, these things are important. Without visibility of the code, people won't use it. And things like IOC containers are a great example. You probably don't want an IOC container inside your package, but you'll almost certainly want your package to be able to be managed in the life cycle of an IOC container. So you're responsible for providing guidance around that as well. There's no point in packaging software without documentation or the kinds of hooks that people need to use it. Otherwise, people just won't do it. But it's cool because thinking about these things is what we should have been doing all along. We just weren't because we were getting away with it. This stuff makes your software better. Seems like a lot of disadvantages though, right? It is just realistic. You do this anyway. You carry the burden for all the software you write and maintain. You've got to consider the project if it's really applicable to others before you do it. And you're probably doing these things covertly. A lot of these decisions do come up in the design of your software. You just deal with it as a matter of course, and it forces you to think about them formally. Luckily, most of the mechanical concerns around packaging can be automated quite easily. It's not an impossible problem. So let's talk about automation and building packages. So what we're going to do is we're going to switch to actual things now. And I'll show you what a package looks like. So let's get it out here. Brilliant. Okay, so first I want to discuss a topology of a project. So this directory layout is part of the work that's been going on towards ASP.NET vNext. So at the moment I'm working on some sample boilerplate projects that explain these concepts well, so you can go and download them from GitHub or Stash, and you can take a look at how packaging and configuration is set up in them. So the source of this layout is a GitHub post. Oh God, get me out of here. Is a GitHub post, that's why. On GitHub, that's just on here. So as part of the ASP vNext endeavor, David Fowler has been soliciting feedback from the community on an ideal .NET project structure that more or less will serve as the strong conventions from this point going forwards. And I say that because new versions of tooling in ASP.NET vNext will expect this topology to be in place, so it can do auto discovery around build scripts and artifacts and folders and tests and things like this. So this has been an ongoing thread for several weeks with many, many people contributing. Generally, people have more or less reached consensus. It's not perfect, but it appears to be a reasonable compromise. So what I'm doing here is I've put together a repository that outlines that structure in Git. And it's kind of self-evident if you really look at it. So what we've got here is we've got the NuGet internals. So I'm going to touch on these in detail later. But when you make a package that uses NuGet, you obviously have to include some kind of NuGet runtime or command line tooling. And by convention, that gets dropped into a .NuGet folder. And it's a config file, an exe, which is a NuGet bootstrapper, some Visual Studio build targets, MS build targets, and a packages configuration. So we'll go into the useful pieces of that later. But ultimately, we end up with artifacts that are destined for your outputs, build for build scripts. There's a little bit of contention around this because by default, a lot of current existing source control tools exclude a folder called build because they expect it to be full of binaries used in build. So the name of build may change to build scripts or something similar. Docs for your docs. Lib for things that absolutely could never be NuGet packages ever. Packages is the folder that NuGet's command line tooling explodes its packages into. So you can see some things in there. Samples for any code samples. Source for your source. Test for your tests. And then at the top level, you have your git ignore, a build command line for Windows, a build shell script for Unix, your top level solution. And then I've added a couple of extra scripts in here around packaging and publishing packages that we're going to go through. So broadly, if you're making a little library in its own repository in .NET, going forwards from kind of this point, it's probably going to look more or less like that. So the first thing I want to do is I want to show you how packaging works in Visual Studio, which is very, very simple. Go away. So I've got an empty solution here that mimics this. So I've got two solution directories with a source and a test folder. And all I'm going to do is I'm going to add a new project. Let's add a class library. My rocking class library. I'm spell class correctly. So the way that most people will interact with NuGet is through the package management Visual Studio extension. So you can manage NuGet packages. You know, this is all very simple stuff. So if you've used any software recently, you've probably done this. So this particular plugin is especially buggy and quite annoying in subtle ways when you use it a lot. For instance, sometimes it defaults to installed packages. So if you search, it'll only search installed packages and it'll drive you mad. But, you know, say I want to install, well, I don't know, that's whatever link it is. And what you'll notice here is it's now resolving dependencies. So NuGet supports forcing license confirmation if you're using visual dialogues. So you get those little pop-ups and you'll see the packages getting added here. So one of the more contentious features around NuGet is the fact that it can execute PowerShell scripts at runtime. There was recently a lot of drama about that because JSON.NET opens a web page using that hook because it helps them pay for advertising, which helps them pay for JSON.NET. And the whole community kicked up a shitstorm because a bunch of very unreasonable people thought that free really meant free all the time. And the fact that one guy was giving away a lot of software that's core to everyone just wasn't enough. And he shouldn't ever be able to pay for his server bills. You may find that running PowerShell scripts disappears. You know, the truth is it's probably not a natural fit for package management. I see everybody's point. You really want your package management to be self-contained and not require bootstrapped installations. However, right now they're in. So you notice now I have Entity Framework and SQL Server pieces along with LinkKit. And the reason is that the LinkKit package has dependencies on those components. So that's nice and easy. We've added a package to a solution. So let's give this a name. My rocking class file. Great. So I now have a class. It's a public class. And I want to do something with that. So I want to publish that class library for other people to use. So what you have to do in NuGet is you have to provide a manifest file that allows you to package. So this is a file called a nuspec file, and you can kind of do anything you like with them. So you can put them anywhere you like, and you can use them as a manifest to describe what files go into packages. So the great thing is there's some really good documentation. So the docs around NuGet are very, very good, and this explains what the file format should look like. But obviously, it's quite difficult to see any of this from here, so I'm just going to show you one. So always use the docs. But what I'm going to do is I'm going to look at one that I made earlier. So annoyingly, because this is a new project structure, the current version of Visual Studio doesn't quite behave correctly. So what I really want to do is remove this again and move it because it's got created at the root of my project. So I'm going to move this into source here. Because unfortunately, at this moment in time, those directories in Solution Explorer are nothing more than solution items. They're not actually links to the physical directories. That's going to change in future versions of Visual Studio, I would imagine. So there we go. So that's now in the right place. So I'm going to just copy one of these and I'll teach you a neat trick. So one of the things that you can do is you can write your nuspec file anywhere, but if you do that, you have to maintain and update all the information by hand whenever you change anything. So one of the things that they built into the NuGet command line tool is that you can package any csproj file so long as there is a nuspec file that lives alongside it with exactly the same name. And if it does, it will infer certain qualities from the project file itself. So if I open this up, it gets pretty interesting. So you'll notice that there's not really anything at all in there. And ideally, in a perfect world, that's how we'd like to keep it. So if you provide a nuspec file that looks something like this, I'm just going to edit this description. Library. You got these tokens are exploded from the assembly info of the csproj file that lives parallel to it. So you can use tokens for this. I can never remember them, but they're all listed in the documentation. Generally, I copy and paste this file all around the place. So you want to make sure you set your tags correctly, because this is what powers search on the official galleries. So rocking and rolling, great. And you can add any dependent framework assemblies that are required by your library. So there's a bunch of stuff that's noticeably absent from here. So if I jump back to the docs, you'll notice there's a whole section on specifying dependencies. So that's really useful. You can set up any package dependencies you like on other NuGet packages. But the cool thing about building a nuspec file that's paired with a csproj is you don't have to. And you can make the command line tool work it out automatically. So in the first version of NuGet, the pairing with a csproj just didn't exist. So you had to make your own manifest, and every time anything changed, you had to go in and modify it. You had to do groups around target frameworks. These days, I've got this class library. Now if I do this, you'll see my nuspec file. Brilliant. What I'm going to do now is I'm going to show you how to actually package that on the command line. So it's incredibly simple. And part of the template project that I'm putting together has some cheeky class library helper files down here for packaging and publishing. So earlier, I mentioned the NuGet exe hidden in the .NuGet folder. So this is one of the usages of it. So it's a little bit arcane. That is the correct set of incantations that you want to use. So if I just take one of these, forget about all the other stuff by now. Oh God. So I'm going to go into source. I'm going to go into my rocking class library. Go back to my notepad file. Bang. Bang. So what this says is call the NuGet executable with pack as the command line against this csproj. Dash symbols means also produce a secondary NuGet package with PDB debug symbols in it, which is super, super useful. Because NuGet servers can also be paired with symbol source servers, and you add the both to your Visual Studio configuration so you can get code level debugging, so you can step into NuGet libraries that you publish, which is the glue over the top of the inability to do it. So until they introduced that, you used to have to manually add the PDB files to the NuGet package. Set the output directory as artifacts, tell it to build before it's packaging. This is brilliant. Include reference projects is the reason we don't have to specify any dependencies on anything else. And I'm going to dive deeply into that in a minute. Non-interactive just means it'll work on a build server. So if I come out here, and I come up to my root directory, so open a command prompt, I paste that in. Hopefully if I spelled everything right. No, something didn't build. And this is interesting. So the reason that failed is because the build tool version that you have installed is very, very important. So Visual Studio 13 made MS Build part of Visual Studio. So if you don't have the correct SDKs installed in the correct places, you get tools mismatches. It's very, very confusing. So for the sake of this example, because I know in this environment we use a hybrid of both versions at the moment, the way you fix that is you force Visual Studio, you force your class libraries to use the previous tools version, which is installed in program files. So very, very simply, the way you do that is you open your csproj. Instead of tools version 12, which is the one bundled in 2013, you just hit tools version 4. There were no versions in between, don't worry. I did have to Google around that to make sure there were no versions in between. So if I run that now, look, it magically built. So it's telling me it couldn't locate an assembly on disk. I'm not sure why. But what we'll see now is if we go up to artifacts, let's delete those secretly. You'll see that I now have my rocking class library and a symbol source package with debug symbols in it. So there's a really useful tool you can get called NuGet Package Explorer. That's what it's called. Yeah, NuGet Package Explorer, which will let us inspect what's happened as a result of that. So you'll notice the dependency is now on link kit. So that got inferred simply from the fact that I have a packages config in my csproj directory with that dependency in it. So when it runs against it, it looks at any packages that my thing depends on, and it automatically cascades them up as dependencies into the package up here. You can see the stuff that got generated. So you'll notice there's a version number in here and an ID's come in here. That's pretty cool. So to prove that that works correctly, probably should close that. Yeah, reload. So the interesting thing about the build tools problem is if you build in Visual Studio, it'll just work anyway. And as soon as you try and do it on the command line, if you don't have the correct build tools installed in the right places, it'll just fail on the command line, which is incredibly confusing if you're, say, trying to debug it on a TeamCity server. So if I go into my properties up here in assembly info, I can change a bunch of stuff. He says, like, say the version number. Let's go to version 2. If I delete those, I'll run that again. You'll notice version 2 in the package name, and we've got a version 2 there. Now there is a list in the NuGet docs of all the replacement tags. So what I normally do personally is I have it bring the author name in from the company name, assembly company, and I put my description in assembly info and have that mapped into the nuspec file as well. And what that means is I just have this wonderful single point of change where I just never touch those nuspec files after the first time I write them. It's quite convenient. Okay, so let me see if I can pull up that docs page. So specifying dependencies, version. Search for a tag that I know exists. Yeah, I'll certainly add the address to the relevant documentation page when I send it around, but I'm not going to struggle around for that now. Okay, so that's the basic use case of adding a package and generating a NuGet package for your own class library. So let's do some interesting things now. So one of the things I can do now, I've got my rocking class library, but say I'm going to add a new project. And this time I'm going to get it right and put it in source. My even better depend or dep, that'll do. Great. So I've made a new class library with a new class in it. Brilliant. And now I'm going to add a reference from my rocking class library up here. Great. So in here, let's just use it, please. So ReSharper has worked all that stuff out. This all builds internally. Great, whatever. Excellent. But now what I have is a reference to my even better dependency. So let's see what happens when I build my package now. First, I'll probably overwrite it, it'll be all right. Yeah, cool. So if I open up this now, you'll see that none of that stuff's changed. And I think, okay, let's do it the old school way. So this is where you secretly discover it's just a zip file. So you'll notice that my even better dependency got packaged alongside it by default. So that's great. But what if I want to publish my even better dependency on its own, which is a reasonable thing to want to do? So I've got two useful libraries. One of them depends on the other, but I want to distribute them as separate NuGet packages so people can pick and choose. So we can go through the same or vaguely similar process that we went through before. If I go into my rocking class library, I'm going to steal its nuspec. Now if I jump into my even better dep, make sure the file names match. So at this point, I'm going to regenerate that package. Cool. I'm going to go up here, I'm going to open it. And what you'll notice now is because there was a nuspec file present alongside the other dependency, it's worked out that that dependency is going to be packaged with the version number available in the csproj as a whole or in that nuspec, and it's added it as a dependency to my rocking class library to start with. So if you've got a solution with 3 or 4 things that you want to publish, that's the best way to do it. Drop in nuspec files next to your csproj, and any references to things that aren't NuGetable will be added as hard DLL references inside the package. Anything else will be swapped out for a package reference to the package that's alongside it in the solution. That's really super useful because it means that instead of having a single repository for every tiny utility library, you can broadly collect them as batches of libraries that move together. And if you're migrating from a massive monolithic solution, it makes it a lot easier to move a clump, drop the nuspec files alongside the csprojs, and then generate all the packages at once. So that's a really, really useful, cool feature. And it means that with absolutely no overhead, you can generate those dependencies. And to bring it back to the build script that I was showing you before, the thing that does that is include reference projects. So that basically says, work it out. Look at the things that are around here, look at your references, and if you can generate package references, God damn it, do it. Otherwise, include the DLL in that package. Okay, so the next bit of the demo isn't a demo at all. I just want to talk a little bit about TeamCity and versioning. So the useful thing about I suppose the mail merge between the assembly info and the nuspec is that it takes whatever version number is present in your assembly info file and just supplants it, because again, previously we used to have to go in and increment these version numbers every time we changed everything. So what I would always recommend if you're doing this is don't do anything that you can forget to do, because you can't push 2 identical package names to a NuGet source. It'll fail your build. So normally what I recommend is enabling TeamCity's assembly info version patcher. I don't know if any of you have seen it. It's hidden about 3 menu options deep. Well, basically it's one checkbox that says, before you build anything, find all assemblyinfo.cs files, and using this format, stamp the version number onto it. So normally using a SemVer versioning technique, which we'll touch on later, the idea is you have a major, minor, revision, and the revision will be whatever the build counter is in TeamCity. And you just get TeamCity to stamp that over every single time, which means that you're never going to fall into the trap of publishing conflicting packages, or whilst the NuGet servers will reject identically named packages. So if you put up version 1, make some changes, package it again, try and push version 1, it won't accept it unless you override it on the command line. And it wouldn't be the first time that I've seen people stupidly think, oh my God, it's not taking my package, let me just force it in there, without thinking that that literally breaks every other single person's software, because what you've done is you've forced a change into their code. Never do that, ever. The reason we have versioning is so we don't do that. So get TeamCity to do the grunt work around that. Don't write post-build hooks that rip commit hashes out of GitHub. And honestly, you'll never look at that. Like the most useful thing you can do if you want that stuff is just add it to the assembly description or something. add the team city build and the checkout SHA to the build description. Let version numbers be version numbers. Okay, so now what we have is we have a bunch of packages that we've generated. They may or may not have dependencies on other packages that we've built and other packages that have come from the big wild internet. What we want to do is, we want to use this for our company, right? So it's all well and good saying that the lovely, awesome guys in the open source world publishing free software can do this, but how do we make this work for us? So NuGet has a concept of package sources. And very simply, this is the thing that lets you have your own NuGet servers internally. So NuGet.config in the .NuGet folder is where all the magic happens here. And this is basically a very, very badly, I wonder if I can encode this. Well, XML. There we go. Now everything's just blue. So this is an example of the kind of package sources that you might want to use and keep in your repositories. So if you look, there's a default push source. So that's quite important because from the command line, at any point, you can type .NuGet/NuGet push starter nupkg, and it'll push all the packages that are generated, say, in your artifacts folder up. Obviously, push doesn't really mean anything without a place that you're pushing it to in some kind of API key. So the NuGet config allows you to set up those defaults, set up default encrypted API keys. So you'll see that here. So basically default push and pull, keys related to pushing, sources that you're pulling from. So, you're probably always going to want the official NuGet package source. So the cool thing is there's kind of a governance piece here that you can actually implement with NuGet where you can use some of the NuGet servers to mirror certain packages. So if you want to whitelist and say, okay, well, we only want to use packages that adhere to these licenses, for instance, or we're only blessing these packages for use. To be honest, I wouldn't advise that in many organizations. It's a lot of waste. But if you're thinking along those lines, you can remove the official NuGet package source and you can add an internal feed and have the internal feed proxy only the packages that you want. So I'm going to touch on them later, but one of the feed providers is a product called ProGet, and it's an enterprise NuGet feed, so it allows you to set up Active Directory permissions and whitelist and blacklist based on regular expressions and licenses and mirror other NuGet package sources and things like that. It's very sophisticated. Luckily, the free version just lets you stand it up as a server, which is really convenient. Also, if you have multiple package sources, you want to have all, otherwise it will only take the top one. You can also itemize the ones you want to be working in here. And that's about it. You also want to make sure package restore is set to true, so it'll download packages on build. So NuGet config will basically look like that in all your library files. And it's the way that you can say our corporate NuGet server is here. Here's some boilerplate that we're going to use for everything. You can also add package sources to Visual Studio. So if I jump back into Visual Studio, now I have to remember where to do this. I believe it's in Tools, Package Management, Package Manager Settings. There we go, Package Sources, not ReSharper. So you can add different available package sources, and what that basically does is it'll go and manipulate the appropriate config files for you. And you can obviously set machine-wide stuff. So it's quite useful if you want to, say, install a machine-wide corporate NuGet server. You just add it in there, and all of a sudden people can search for your packages, and it just works. Very, very nice and easy. That, I believe, is the end of this demo. I've covered interdependent packages, generating from NuGet, project topology, and I suppose, yeah, the only thing that I've not touched on is publishing. So if you look at this folder structure, I'm going to open up these files here for you so you can kind of see what they're doing. Generally, the things that I maintain by hand The build.command is fairly trite and trivial. I tend to keep that in the root, build the solution in release, build it in debug, which means you get everything twice with your PDBs generated. So if you run that, that's your absolute, I know that that works. Some people like to bootstrap in their unit tests there as well, just to give it a good clean pass to prove that when you pull, everything worked. I built and I tested. So bootstrap NUnit on the command line, that kind of stuff. Package.
So just to quick, so when you run that package, it's got dash build.
It will build again. Yeah, it will. So the idea is these are completely discrete steps, not necessarily a chain. If I package here, and package will build in release mode if everything's in debug to start with, for instance. If I package here, I tend to specify exactly the csprojs. So you could blatantly write a really trivial PowerShell script to say, go into the source folder, get me a list of all the csprojs that also have a nuspec file with the same start, and run that command over each of them. Generally, with my own open source stuff, it's been up to 2 NuGet packages per repository. So I've never actually felt the urge to write that PowerShell script, but I reckon it'd take anyone that has a vague appreciation of PowerScript about 5 minutes to write it. And publish. So that's the simplest publish command. As long as you stick all your packages into artifacts, and as long as you have a NuGet.config in place with an API key that works and a push source that works, you can just on the command line type NuGet push. Obviously, if you're making this an open source project, for the love of God, do not put your API key in there. So the workaround for that is you can set environmental variables with API keys and things like that. So what you would normally see is the publish job on a build server would have the API key in it. So either if you're using TeamCity, what you would probably do is take the API, would be write a build step that sets the environmental variable that NuGet looks at immediately before the step. So you'd set the API key and then push it. I believe the current TeamCity integration has a box for it, and you can just paste your API key in and it goes. Similarly, I use a Cloud CI for a lot of my stuff called AppVer. They just have a add NuGet, paste your key in there, done.
So then in terms of like building and deploying the site, so would TeamCity grab the packages separately rather than being
exactly that? So if you had a project that depended on packages, as long as the NuGet.config file in the applications.NuGet folder pointed at your package source, when you build, before the build, it'll do a package restore.
Sure, yeah.
It'll say, list me, well, first it says, find me every packages.config in this root. Now find me all of the packages listed in packages.config. Do I have them? No, get them. Do I have them? No, get them. Great, now build.
Yes, I think some of our sites have got a separate packages
Config.
build. Yeah.
Yeah. So and you know, that's fine. I mean, you can download the packages separately, but you may as well just set the flag and make NuGet do it automatically, because it will work all that stuff out for you. And the nice thing about it is it'll keep local package caches on machines and things like that. The one thing you should never do is check in NuGet packages to your build, to the applications that depend on them, because all that will do is bloat your repository. It's also important that you don't publish every single change you make, but I think I have a slide on that later. If not, I'll just say it again. So if I now jump back to the slideshow. No, that's why I never control F5, because all it ever does is refresh. Okay, cool. TeamCity and NuGet. So TeamCity has built-in support for packaging and publishing with NuGet, as we just discussed. So it's very, very tempting when you see the big fat checkbox in TeamCity to click enable NuGet feeds. So what that does is every time TeamCity generates a NuGet package, it makes it available in a feed. Sounds awesome. And I've not used the latest version of TeamCity, 9 something, I think. But certainly up until TeamCity version 8, the performance of that package feed was so incredibly terrible that if you committed a lot, like did real work, because it generates packages on every build, and that's fine, generate the packages by all means, the package feed got so big that it just ended up hanging Visual Studio when you tried to add a package. And that happened, I saw it happen in about 3 months of publishing packages. So you can prune old packages to reduce that friction, but ultimately, as far as I'm concerned, that's just waste, that's noise. And I don't honestly believe that we should be publishing every single package. What you should be doing is treating your packages like software that you launch, and the publishing point is when you're happy to release. It makes sense. It's the ceremony around it. I'm happy with the tests. I'm happy with the documentation. This is the point we go. Publish the package. So you can produce pre-release packages. I think the next slide might be about that. No, it's not. So a NuGet feed can be a local folder, an NFS share, NuGet-based HTTP feed built on OData. So the kind of cool thing is for your dev workflow, folders are okay. On my local machine, I have a C local packages that I spit things into. So for instance, if you're thinking about frictions in your dev workflow, say you've got an application that you're building and it relies on a package you also maintain, and you need to change the package to change your site. What you don't want to be doing is get stuck in this horrible feedback loop of permanently publishing stuff, only to re-download it, to publish, to re-download, to test your code. I mean, obviously there's a bounded context problem there where really you should be test driving your packages before you integrate them, but there's a bit of reality there where sometimes some people just want to see the thing working. So what I tend to do is set a local package source globally on my system, and I'll just copy and paste generated packages into that package source, and I'll just add them. And that lets me test stuff without having to actually make it available to other people. It's a lot cheaper than making public package feeds in other places. But obviously you probably want to provide a HTTP server for your teams, because the teams are potentially distributed, and NFS shares ain't a great and scalable, fast way to do things. So ProGet's really good. I mentioned it before. And the UX of ProGet is double-click an MSI installer on a server, click next about 4 times. There you go, you're done. Set an admin password. It's really like, I've installed this in 4 or 5 different organizations, and I've never had it take me more than 30 minutes to set up. So that's very good. And it's free, basically. It's free for most people unless you want to do the big enterprisey governance piece, which I'd recommend against anyway. A couple of the people I've put it in for have paid for it anyway, because I think it's about 700 or 800 quid for a perpetual license, forever, fully licensed. It's kind of a nice thing to do. Hosted. So NuGet offers a hosted NuGet as a service solution, and they offer authorized feeds and lockdown and things like that. They're very popular. I know Microsoft use NuGet for a lot of their internal stuff, which is quite ironic considering they have a NuGet gallery project as well. But I think a lot of the ASP.NET team use it for pre-release stuff. So choose your feed host. You mentioned that you don't publish a package on every build. If you want to publish a pre-release packages, there's a versioning reference. But in short, it says use SemVer. So does anyone know what SemVer is, or is this a new concept? So real trivially, SemVer, and I think let's jump out here. SemVer. So here's a big spec that's really boring. The important bits are right there. Upgrade the major version you make when you make incompatible API changes, minor version when you add functionality in a backwards compatible manner, and patch when you make backwards compatible bug fixes.
So in terms of, say we've got a bug in like, one of the packages, like the class library. Obviously, we usually need to go through QA and all that stuff. So could we do a pre-release to get out to the QA servers and then do it?
So you can, but you may as well just fix it properly and release it. You can pre-release and do that. But again, think think that the package is completely distinct from everything else. It's like it's in its own stream and its own flow. So if there's a bug in the package, treat it like a bug in a product that stands alone, write tests around it, verify it. If it's a bug and you can patch it, and basically the patch version means I am changing behavior because I told you something behaved like this. Actually, it didn't. And the fact that it didn't is breaking everything. It's not that people have built around this behavior and are expecting it. It's this is a bad problem. We need to change it. If it's something that changes expectations, changes APIs that are in use, that's a major revision. What that means is your packages might version up pretty quickly, but who cares? We're not going to run out of integers. Like, it's good. We got numbers.
I'm just thinking in terms of our QA process, like obviously.
To be honest, don't think about it. I don't think it's not relevant.
When you consume a package, you consume a particular version of it.
And you choose to.
Exactly. So you're locked at a moment in time.
So we've not. So obviously.
Let me explain the workflow. So you need to change a package. I go and fix it. I verify it. I publish it. Okay. At that point, you published it. Nothing has changed. The bug in your software still exists. You go into your software, and you either using the package management command line or the tool. You click upgrades, and it'll show you that there's an updated version of the package. You can update it. You can even specifically update to certain versions. So that update tool allows you to give it an optional flag that says include pre-release.
Yeah.
So pre-release, here be dragons. It's supported because people want it, but be very, very mindful. So I think it's here, actually. Okay, so this is how SemVer works. So if there's a string in the version number, it's pre-release. When you're ready to release, just remove the dash and the string, and that version is considered higher. So pre-release versions are given precedence in alphabetical order. That's an important thing to remember. So that's from low to high. So you can abuse that all you like to do pre-release stuff. But pre-release is a bit confusing because all pre-release really says is, I've given you a package. Another package might arrive with exactly the same name that changes something. Or I might randomly launch one with a different set of characters after it. I'm not really telling you what's changing in my API. This is the Wild West. This is completely unpredictable. And that's okay if you understand and accept those compromises while you're working. So there's no reason you couldn't launch and publish a pre-release package with an attempted fix, upgrade your software to include that pre-release package, vet it, potentially ship it because it verified and worked, and then launch the exact same package without the pre-release suffix. Like, that would be an okay workflow, but really, I don't know. I think I would feel a lot more comfortable if people were treating the packages like deliverables that were vetted and worked and behaving in that manner. So yeah, remember, you're going to have to support it and disclaim it. So a few final tips. Make sure you use the facilities provided by the nuspec file. Make sure you set tags to make your package discoverable in gallery search. Use the notes elements to provide release guidance and upgrade hints. Those notes appear in the NuGet gallery. So if you use the notes XML element, it's really worthwhile. Always link to the project website or source 100% of the time. Otherwise, if you think about the workflow of discovering packages, a lot of people discover packages in the NuGet either gallery or the search in Visual Studio. You kind of want to click and see something meaningful. If you don't, you'll skip it. I skip it. If you're going to make the package public, upload it to NuGet.org gallery.